Hi everybody, it's Miss Kim. Here are your notes for lesson 10.5. I am redoing the video because apparently my original video went off of the viewing screen for some reason, so you weren't able to see all of my writing, so I'm starting over. Okay, we are learning about angle relationships in circles, and our first exploration looks at when we have a angle formed by a chord like BC and a tangent like line B. All right, so what that does, you guys, the vertex is still on the circle. So just like our inscribed angles, this angle X will be half of its intercepted arc. And you're welcome to play around with the geometry tools to discover that on your own. Our second exploration looks at angles formed by intersecting chords. You'll see you've got two chords that intersect. So if you're looking for angle X, that's going to be 1/2 the sum of the arcs. Sum tells us to add, and the way we know that is the vertex is inside the circle, okay, but not on the center, just inside the circle. All right, here's the beginning of our lesson. You'll need to come back and define circumscribed angle after we define it. Our tangent and intersected chord theorem is the one I just showed you. So if you've got a chord intersecting a tangent, that vertex is on the circle. So we learned that it's the angle is half of the arc. Now there are two angles and arcs here. So angle 1 is half of that red arc. Angle 2 would be half of this blue arc. Our next core concept, if you have intersecting lines and circles, you will see that vertex falling either on the circle, inside the circle, or outside the circle. The angle, if we're going to call the angle X, so that would be this angle right here. That's 1/2 the arc when it's on the circle. It's 1/2 the sum when it's in the circle. And when it's outside the circle, it's 1/2 the difference of the arcs. That tells us to subtract, where adding tells us, or the sum tells us to add. Okay, and again, you guys, this is just another example of what happens when the angles are inside. So if the vertex is inside, remember we said we would take half the sum of the measures of the arcs. So the problem here, though, sometimes they give you two of them. So angle 1 will be half the sum of those blue arcs. Angle 2 will be half the sum of the red arcs. Don't forget each chord is a straight line, so you have linear pairs on each chord as well. Okay, the angles outside the circle theorem. So there's different ways you'll see angles coming from outside the circle. The first example would be with one tangent line touching once and one secant line touching twice. So that would be angle 1 is half of the difference of the intercepted arcs. Okay, so you're going to have to find this bigger arc and then subtract the smaller arc. The next example, you have two tangent lines touching once. So again, we're going to go 1/2 big arc minus small arc. And then our last example is with two secants. They touch the circle twice. So angle 3 would be half the difference of the big arc minus the small arc. So in kid-friendly language, 1/2 the difference And don't forget to go big minus small. Okay, the circumscribed angle is one that has two sides that are tangent to the circle, so it would be this angle right here. Angle X would be your circumscribed angle. Now that vertex is outside the circle, so normally you would just say the angle is half of the difference, like we just said. The only difference with this bottom one here, if they give you, you'll notice this central angle here, if you get like 110 there, then you know to get angle D, you could just go 180 minus that central angle. So that would give us a 70-degree angle there. Okay, so that's only if you have central angle information. Otherwise, you have to use the 1/2 the difference of the arcs. Okay, let's practice some of that. So here we say we see line CD is tangent. Find the measure. So the measure of arc ABC or angle ABC is this one. So we can go 180 minus 70. Right? If this is 70, this part has to be 110 because they make a straight line. And to get arc AB, we can see that 70-degree angle intercepts that. So this will just be 70 times 2, which gives us 140 degrees out here. Okay, now to find the other arc, this guy, that one is 110 times 2. Okay, so this angle goes this way, that is 220 degrees. Whoops, too many 2's there. There we go. All right, let's do the next one. Arc ADB is 220. Find the measure of arc AB. So we'll go this way, and since that's the rest of the circle, we just subtract. So we get 140 over here. And then to find ACB, that's this little angle right here. Okay, so let's trace that. That has endpoint A and endpoint B. Okay, so that blue arc is the big one. Now this little green one here is your small arc. And if this angle is 21, this arc has to be 42 because it's 21 times 2. So now we can go, okay, angle C, we'll call that X, is 1/2 of 140 minus 42. And that gives us 49 degrees. That's for that angle C right there. All right, find the value of X. All right, you guys, so 5's pretty straightforward. 7's a little bit of a curveball. 5 would be a vertex in the center. So we know it's half the sum of the arcs. So this is just X equals 1/2 50 plus 92, which is 142. Half of that is 71. Okay, now curveball version of that. Let's do it again. They gave us 97 and 35. That could give us one of these angles, right? Let's call that Y. And then they want us to solve for X, but that intercepts these angles. Okay, so we got to do that thing where let's solve for the one that we can, and then we'll do 180 minus that, right? So this 5x plus 14 has to be 180 minus y, because those are a linear pair. All right, so first we'll solve. Let's see if I can zoom this in, hopefully still keep it in your viewing window. Let's try that. Okay, so we'll go y is half 97 plus 35. That's 132. So that means y is 66 degrees. Okay, now 180 minus that gives us 114. So that means this angle here next to y, with that 5x plus 14 on it, that has to be 114. Okay, so then we can set up 5x plus 14 equals 114. And we get x is 20. Okay, 2 more vertex outside the circle. So we're going to go 38 is half the big arc x minus the small arc 72. Got to distribute that half. And we'll divide by 2. So we get 144 equals x. All right, one more of these. Vertex is outside. We're going to use that same formula. So the angle is 28. It's half of the big arc, 4x plus 8, minus, now notice you got 2 terms on your small arc, so keep it in parentheses at first so you can distribute. Really important, because it changes the sign. You're going to get minus 3x minus 2. All right, then you can combine like terms. We'll subtract 3. And then we'll multiply by 2. So 50 equals x. Alrighty, you guys, that's it. I hope that made sense. Please let me know if you have questions. Thanks for watching and listening.